Hello everyone, welcome back to this channel. Today we are going to learn about descriptive statistics. This simply means that you are interpreting the data without making any assumptions. How? Let me give you a simple example. Let's say in your class there are total 150 students and your teacher wants to know the average height of the class. So he can do this in two ways. First, he can measure their height and make an average. Second, he can simply select some students measure their height and make an assumptions about the average height of the class. Okay. So in first scenario, he is considering every student, he is measuring everyone, total 150 students. That means he is considering the complete population. So these techniques, these measurements comes under descriptive statistics. But in second scenario, he is considering some students, he is not considering everyone. So he is taking a sample from the population. So here the techniques comes under inferential statistics. Okay. So statistics can be divided in two types. Descriptive, where you are considering the complete population, total 150 students. And next one is inferential statistics, where you are considering some students, 10, 15, 20, any numbers, not everyone, the sample. Then it comes under inferential statistics. Okay, so today we are going to learn about descriptive statistics. Okay, see here total six types of measurements that comes under descriptive statistics. First one is measures of central tendency, measures of dispersion, measures of shape, frequency distribution, percentile and quartile. Next one is summary tables. Okay. Now first, how can we calculate the central tendency? By mean value, median value, mode value. Let's understand all these things in details. Okay. Now measures of central tendency means you are trying to identify where the most values in a distribution fall. Okay. So identifying the central point within a data set. Okay, so we have to calculate mean value. Mean is nothing but the average sum of all numbers divided by the number of values. Here I have taken a data set. Here you can see this is a list 85, 90, 88, 92, 87. So if I want to calculate the mean value or we can say the average value of the data set, I just simply can add 85 plus 90 plus 88 plus 92 plus 87 divided by the number of values, that is 5. So I can get the mean value. Okay. So here I can understand that the maximum values or we can say the most values in the distribution in this data set lies near 88.4. Okay. So if you have a big data set, you can simply identify the central point. You can understand where the most values lies in the distribution. Okay. Now there are other types of means also. One is weighted mean. Number two is trimmed mean. Weighted mean is used when you consider its corresponding weight. Suppose some values contribute more to the overall average than others. Like here, there is a data set 2, 3, 4, 5. But every data has different types of weights. So here if I want to calculate the weighted mean, I have to multiply each data point by its corresponding weight. Then summing all the products and then dividing by the sum of the weights. Okay. This is mainly used when every data set has different weights in the data set. Okay. So here I have just simply written a code like for x comma w in g data comma weights. G function will consider first value of data, first value of weight. So x will be 2, w will be 0.1. After it is assigned, they will be multiplied x into w. Then it will sum all the products and divide it by the sum of the weights. Okay, so simply this way you can calculate the weighted mean, but you don't have to do these things because numpy function has already provided np.average values, comma, that means data here, comma, weights equal to weights. So these two parameters will simply calculate the weighted mean from the data set. Okay, you don't need to write the coding because NumPy has some ready-made array. We have already studied these things in NumPy classes. np.mean, same way you can calculate np.weighted mean also. For that, you have to call the average function and pass the values. Fine. Next, understand trimmed mean. Trimmed mean simply means that removing certain percentages of smallest and largest values in the data set and then calculating the mean of the remaining value. Okay. So here in this array, you have to remove some smallest values, some largest value, depending on your wish. Like here, 10 percentage from both ends have been deleted, or we can say trim. Then you calculate the mean value from the remaining data set. That is what is trimmed mean. Okay, for that you have to call the trim mean function and you have to pass these parameters. Simple. So we have completed measures of central tendency mean value. Next one is median. Median means the middle value of the data set. First, you have to sort this. You have to make it ordered. Then you have to find the middle value, that is known as median. So it separates the higher half from the lower half. So you can understand the central point of the data set. Okay, for that you have to use median function in NumPy array. np.median x, it will provide you the median value. Fine. Now mode means that value which occurs most frequently in the data set. Here see 85 occurs once, 78 occurs twice, 92 once, 87 once. So what is the mode value here? 78. What is the count? Count equal to 2. So you can understand that what are those data which occurs most frequently in the data set. Okay. So we have completed the measures of central tendency. Mean value, trimmed mean, weighted mean, median value, mode value. Okay. Next, understand measures of dispersion. This is exactly opposite. Central tendency means you want to know the central point. Dispersion means how much the data is spread. What is the variability in the data set? Okay. So we can say how much the data values in a data set differ from each other, or we can say differ from central tendency. Fine. So how can we calculate this? First one is range. Range gives you the maximum values. The minimum values finds the difference between maximum value and minimum values in a data set. Here see, you can see there is a data set. So first you have to find the maximum value, the minimum value, then difference. That is what is known as range. So you can understand how much the data set is spread. Fine. Next one is variance. Variance simply means to find how much each number in a data set differs from the mean of the data set. Okay, suppose see here. First, I have to calculate the mean of this total array. So I can simply write np.mean, mean function in numpy array. It will calculate the mean value 2 plus 4 plus 4 plus 4 plus 5 plus 5 plus 7 plus 9 divided by total number of numbers. Okay, now when I have got the mean value, here the mean value is 2, 6, 10, 14, 19, 24, 31, 40 divided by 1, 2, 3, 4, 5, 6, 7, 8. That means 5. So here the mean value is 5. Now I want to know that each number in the data set 2, 4, 7, 5, 9 is how much different or how much differs from the mean of the data set. Okay. So 2 minus mean value is 5 minus 5, 2 minus 5, 3, square of 3 that is 9, 4 minus 5 that is minus 1, square of 1 minus 1 that is 1. Okay, same 1. Next, 0, 0, 7 minus 5, 2, 9 minus 5, 4. So 2 square plus 4 square. Now if I add all these squares and divide them by the length of the numbers, that is 8, then we can get the variance. So we can understand that every data set, every number in the data set is how much different from the mean of the data set. Okay, so how much the data set is spread. We can find the measures of dispersion. Now a simple question I can ask you that we can simply subtract this. But why we are making a square? We want to know how much it differs. So we can simply subtract. But why square? Because see, first it is giving us a negative number. 2 minus 5 minus 3. 4 minus 5 minus 1. Minus 1 minus 1. 0 0 2 4. Here it is giving positive numbers. So if I simply add negative numbers with positive numbers, then we will not get the desired result. That's why we are making a square so that the negative numbers also turns into a positive number and we can get what we actually want to get. Now spread out a set of values in the data set. Okay, that is what is known as variance. How much it differs from the mean value. Now next one is standard deviation. Okay, before that let me tell you one thing, that we don't need to calculate this much of coding. We just can simply use VAR function that is already in NumPy library. All you have to do, import NumPy library and apply the var function on this dataset. Then you can get the variance. Okay. So all this coding simply can be done in a single line. Fine. Next one is standard deviation. Standard deviation means the square root of a variance. Here we have made a square. So we just simply square root the result, the variance. So we will simply square root 4.0. So here 2 will be the standard deviation. See here. Okay. Here I have written a mistake. Here it will be standard deviation, not variance. Okay. So these are the simple things by which we can know how much the data is spread. Measures of dispersion. So as of now, we have completed measures of central tendency, that is finding the central point, finding the middle value. It can be done in three ways: mean, median, mode. Mean has other types of means also, like trimmed mean, where smallest values and largest values are simply removed and the mean is calculated on the remaining values. Second one is weighted mean. When every data set has different weights, we calculate weighted mean by multiplying each data points with its corresponding weights. Next, we studied about median. First, we have to order the data set. Then we have to find the middle value. So we can get the middle values of the data set. Next, we have studied mode. Mode means the value which is occurring most frequently in the data set. Okay. Next, we have completed measures of dispersion. There we have studied about range. Range, the difference between maximum number and the minimum number. Next, we have studied about variance. That means how much each values in the data set differs from the mean value. Next, as variance is calculated in square form, we are just making a root of variance and we find the standard deviation. So all these things, mean, median, mode, gives us the central point of the data, and all these things, range, variance and standard deviation, gives us the dispersion or spread of the data set, exactly opposite of each other. In our next class, we will study about all these things. Till then, bye. Happy learning. Hello everyone. Welcome back to this channel. So let's continue our descriptive statistics session. As of now, we have completed measures of central tendency for finding the central point of the dataset. Next, we did measures of dispersion, that is finding the variability in the dataset. And now we are going to study measures of shape. We have to read skewness and kurtosis. Okay. Now first understand what is measures of shape. Measures of shape means numerical values that describe the distribution's symmetry, thickness, flatness. Now first, what are all these terms? Suppose you have a data set ranging from 10 to 100. Okay. 10 is the minimum value, 100 is the maximum value. But if in your data set there are values 10, 12, 15, 16, 18, 13, 17 and very few values like 99 and 100, then you can say the data is skewed because maximum values are near 10, very few values near 100. So the data set is not symmetrical. Now if you have a data set like 10, 11, 95, 98, 99, 93, 94, 97, 100. Then also your data set is skewed because maximum values are lying near 100. But if you have a data set 10, 20, 35, 45, 67, 74, 85, 93, 100, then you can say that the data set is symmetrical. Okay, so our job is to find the symmetry of the data set, whether the data is skewed or not. Skewed means a measure of asymmetry. Data is not symmetrical. Now we want to know how much asymmetrical the data is. For that we have to calculate skewness. Okay. Now what is positively skewed? Positively skewed means the right tail is longer or fatter than the left tail. Let me show you. This one. If you draw like this one we have studied in C1. This is a density plot. Probability density this side and continuous variables along the x-axis. Okay. So we are trying to find, let me show you, the probability density of the continuous variable. Okay. That is KDE plot. You remember KDE plot? We have to find the probability density of the continuous variable by calculating the area under the curve. Because for continuous variable, we cannot calculate probability. Probability is 0. So instead of probability, we calculate probability density. Fine. So now we have to see whether the data set is positively skewed, negatively skewed, or the data set is symmetrical. Okay. Now after we plot, if the data looks like this one, like the right tail, this one is known as tail. If the right tail is longer than the left tail, then we can say this is positively skewed or right skewed. But vice versa, if the left tail is longer in comparison with the right tail, then we can say the data set is negatively skewed. Fine, this one is positively skewed. Why? Because the right tail is longer. Maximum data sets are lying this side. Now this one is negatively skewed because maximum data sets are lying this side. Okay. And if the data is symmetrical, then how will it look? Then it will look like this. Then it will look like this one. Okay. Almost same in both of the sides. Then we can say the data set is symmetrical. The last data set. Fine. Okay, now let me show it to you. First, first I have to download C1, Matplotlib, NumPy, and I have also downloaded a skew function to measure the numerical value of the skewness. How much the data is skewed. Okay, first I have generated some data by like some exponential numbers of 1000 values. Total 1000 values data set. I mean total 1000 data points will be generated random. Okay. Now just let me show you data skewed. Okay, these are random exponential numbers. Total 1000 numbers. Fine. Now if I want to plot this, then sns dot kde plot. We studied this during C1 library. Inside this, we have to write data skewed. Now see if I run it. Clear? You can see the data set is skewed, positively skewed or negatively skewed. Tell me. Positively skewed because the right tail is longer. Now if I try to measure the skewness, then I can write skew function. I have to use the skew function on the data skewed. Now let me run this one. Just type skewness, then I can see the skewness value. Okay, fine. So we can measure the numerical number, we can plot, and we can understand that the data set is not symmetrical, and we can understand whether the data set is skewed. If skewed, then positively skewed or negatively skewed. If not skewed, then the data set is symmetrical. Fine. So we can find the shape of the data set. Now the next one is kurtosis. Kurtosis is also simple things. Kurtosis means the measure of tailedness or sharpness. Okay, if it has high kurtosis, that means the graph has a very tall peak. But if it has low kurtosis, that means the graph is more spread out. Let me show you. If it looks like this one, that means this one is longer and this one is also longer. Tails are also longer and it is also highly peaked. Then you can see this is high kurtosis. But if the tail is also short and it doesn't have high peak, then it may be called as low kurtosis. Now high kurtosis means you can have a data set here, you can have a data set here, you can have a data set here also. So you can see that this may be 10, this may be some data set, this may be some data set. So there are so much variability in the data set. Okay, but here means the data sets are very near to each other. So less chance of having extreme values and high chance of having extreme values. Okay. So by plotting this, by measuring the skewness, you can understand whether the dataset has extreme values or the dataset is distributed symmetrically. Fine. Descriptive statistics is all about knowing the dataset. Central tendency helped us to find the central tendency. Dispersion helped us to find the variability, and measures of shape helps us to find the tailedness or sharpness, whether there are extreme values or the dataset is distributed well. Fine. Now, if you want to know the kurtosis value, now if I run it here, I have just generated a random array, numpy array, and then if you uh, call the kurtosis function and pass the dataset, then this is the kurtosis value. Okay, so negative kurtosis means that the distribution of the data is flatter than the normal distribution. If negative kurtosis will look like this, if the normal distribution is like this one, sorry for my drawing, then the negative kurtosis will look like this one. Okay, so the dataset has fewer extreme values and less variability. Okay, but high kurtosis means it will look like this one, having more extreme values, longer tail, and high peakness. Okay, so normal distribution means the maximum values are near mean. Okay, now low kurtosis means the dataset has fewer extreme values in comparison with normal distribution, and high kurtosis means the dataset has more extreme values in comparison with normal distribution. Fine. Now let's understand the next topic, that is frequency distribution. Frequency distribution is a summary of frequencies with which values occur in the dataset. So it organizes the data into groups or intervals and shows how many times each value or the range appears. Histogram, we studied histogram while studying matplotlib and also in Seaborn. Just let me show it to you once. You need two libraries, matplotlib or Seaborn. You can plot using matplotlib. You can plot using Seaborn as well. Okay, so here one data is generated, numpy array, then plt.hist. That means it is done using matplotlib. If you want, you can write sns.hist also. Okay, data. Now bins, you can give 10, 15. I have given auto. That means you decide. And if you want, you can give edge color, or if you don't want, you don't give. You can find the frequency. Okay. So how many time 2 is occurring? How many time 3? How many time 4, 5, 6, 7, 8? Okay. So the data set is divided into 5 bits and you can calculate the frequency. Okay. Now let's understand measures of position. Measures of position means finding the location of the data point. Okay, how we can do this? By these four ways. If the data set is divided into 4 parts, it is quartile. If divided into 10 parts, deciles. If it is divided into 100 parts, percentile. Or if it is divided into 5 parts, then quintiles. Percentiles are mainly used everywhere. Okay, we also used box plot to see the percentiles. Now, let's understand what is percentile. Percentile means the value below which a percentage of data falls. First, don't get confused with percentage. Percentage is a different thing. That means how much you have scored in 100. But percentile is completely different. It is like finding the position. If you have scored 90 percentile, that means you did better than 90% of the people who took the test. If you have scored 80 percentile, then you did better than 80% of the people who took the test. Okay. So it gives you the position relative to the group. It is not percentage. Okay. So mainly we use percentile to find the location of the data point. That means where the data point lies in that data set. Clear? Now see how we can do it. First, we divided the data set into 100 parts and 25 percentile is the first quartile. That means 25% of the values lies below this point. 75th percentile means the third quartile. That means 75% of the data points are lying below this data point. 50th percentile, that is the median, or we can say 50% of the data points are lying below this particular data point, this value. Okay, now let's see how to calculate using Python. See, this is the data set. And if I want to calculate 50 percentile, that is the median of the data set. Now see, it will show me the, just let me print this, percentile 50. Make it 50. Because I am calculating the median. So it will give me the median of the data set. Okay, so 4.5 is the median of the data set. So I can say that 50% values of this data set are below 4.5. If I calculate percentile 100, then what will be the answer? I have to give 100. Now see, oh, I'm sorry. Now see, 8. That means 100% of this data set are below 8, because you also can see that 8 is the maximum number. If I make it 9, then 100% of this data set will be below 9. Fine. Okay. Now let's calculate 25 percentile. So I want to know the 25 percentile of the data set. Now let's see what is the result. If we run this one, we run this one. See, so we can say that 25% values in this data set are lying below 3.25. Clear? So this is what is known as percentile. You can calculate any number, any percentile, like 5 percentile, 10 percentile, 25 percentile, 50 percentile, whatever you want, 99 percentile, and you can understand that how many values are lying below this data point. Now next understand quartile. Quartile means the data set is divided into 4 parts. That is 25%, Q2 50%, Q3 75%. Okay. Same way, just the data set is divided into 4 parts. That is why it is not percentile, it is quartile. Okay. But the concept is same. Now next point is interquartile range. It will be used a lot in our project. We have to calculate interquartile range for calculating what? If you have seen my project, then you know we have already used that while calculating outliers, because for outliers it will help you a lot. This is a which plot? Can you tell me? This is a box plot, because here I can find the 5-number summary. What are those 5-number summary? Lowest value, highest value, 25th percentile, 50th percentile, 75th percentile. 50th percentile means the median value. So the difference between the 25th percentile and the 75th percentile, that is known as interquartile range. Okay, we have discussed this before also. Still we have discussed now. I hope you have not forgotten it. So the difference between the third quartile, or we can say the upper quartile, and lower quartile, or we can say the Q1, that is known as interquartile range. Okay, this range is known as interquartile range. Okay, these are the 5-number summaries. Box plot can be used to visualize these 5-number summary. Fine. So we have understood the measures of position. So we have completed measures of shape and frequency distribution, percentile and quartiles. Fine. Now next understand summary table. Summary table is really easy. That is simply counting and making the sum. This is just like giving a overview of data's main characteristics. Count means the length of the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So just length of the data set is count. Simple. And sum means just adding them. 2 plus 3 plus 4 plus 5. So 70. So this is summary table. So we have completed descriptive statistics. Congratulations to you. Okay. Now I will ask you some questions. Try to answer them. What is measures of central tendency? Finding the central point. What is mode? Can you tell me what is mode? Finding the value which is appearing most in the data set. Okay. What is standard deviation? Can you tell me what is the standard deviation? How to calculate standard deviation? By calculating the root of variance. Tell me what is kurtosis? Kurtosis means finding the peakedness. If the peak is lower, then whether it is high kurtosis or low kurtosis, it is low kurtosis in comparison with normal distribution. What is normal distribution? Normal distribution means the maximum data points are near to mean. What is symmetrical distribution? That means the data set is symmetrically distributed. What is positively skewed? Positively skewed means the right tail is longer. And what is quartile? Quartile means the dataset is divided into 4 parts. What is quintile? The dataset is divided into 5 parts. What is deciles? The dataset is divided into 10 parts. What is sum? Sum means sum of all the numbers. Okay. So congratulations. Bye. We will meet in your next video. Till then, bye. Happy learning.